Hello everyone. Today we are going to look at the most easiest process scheduling algorithm. So FCFS, that is first come first serve. It is called first in first out if it were a page replacement algorithm. So there are 2 points to note. Firstly, it depends on the order of the object received. If it were process, the order of the process matters. Uh, Whereas if in a page, the page. Secondly, it is a non-preemptive algorithm. What do I mean by non-preemptive? That is, if a process is scheduled or if it receives the CPU, at that point onwards, until and unless it gets completed, it won't be given to another process won't get scheduled at that point. So that is non-preemptive. So these 2 points are to be remembered. I've prepared a chart, a basic table. Here it has the processes, the arrival time, the burst or execution time, and the service time. So what do we mean by burst time? This is the time that is needed for the process to get completed, the amount of time. This is the arrival time. So on this basis, we prepare a Gantt chart. I've already prepared it. How do we prepare it? The Gantt chart always starts from the 0th time. On this point onwards, we have got our first process that has arrived and it takes 5 units of time. So we schedule it, we give it a slot basically here from 0 to 5, and this is acquired by P0. At this point onwards, since we have told that this is a non-preemptive type of scheduling. So what do we do? Even after we got a process that was arrived at 1, that is at some place here, but we waited till this P0 got completed and then we scheduled P1. So on this point onwards, for 3 units of time, P1 gets scheduled. So it got completed actually after 5 plus 3, that is 8 units. And this period that it was waiting around from this first, the time it got arrived, and till the time it got started, that is the point at which it got started, the execution, that time is called the waiting time. We will also find the formula for it, but this is the basic idea about it. Similarly, the turnaround time, what is it? That is the completion time, that is the point at which P1 got completed and the time at which it arrived. So the time taken from this arrival, that is at 1, to the point at which it got completed. That's the basic idea about turnaround time and waiting time. So all these things are basically to reduce these times, turnaround times, waiting times. And for these, we have used these various scheduling algorithms and processes. Okay, so after we have done this, we prepare this Gantt chart in this similar fashion, the way I've done. P2 gets scheduled after P1. It already arrived at 2 at some point here, but since P1 was executing, P0, P1, and then we scheduled it after this. So 8 plus 8 gives us 60. So it waited till here, like it got executed at this point, after which P3 got executed at this point. So 16 plus 6, that is 22. On this basis, we prepare the chart for turnaround time and waiting time. So I've already created this table. We can fill it accordingly. So basically for P0, it got completed at, at this point, that is 5. So P0 got completed 5. The turnaround time for this, what will it be? As I said, the turnaround time was the time at which it arrived, and the time at which it arrived and the time at which it got completed. This time, the time period between them. So let's look at the formula first. The formal formula, but we understood the idea for it. So that is the completion time minus the arrival time. That is what we had done as well. Similarly, waiting time is the turnaround time minus the burst time. That is the execution time. If you look at this formula and think upon it, what I have explained previously, you can try to assimilate some kind of relation between them. You can comment down if you understand that point. So yeah, completion time. So we'll first write the completion times of each process so that we understand how it works. Gantt chart gives us the completion time. So P1 got completed at 8 on 8 units, then P2 at 16, P3 at 22. Okay. Now, what will turnaround time be? Completion time minus the arrival time. Okay. So what was it? 0 for P0. So 5 minus 0 as we did. So it should be 5, just 5. So 5 minus 0 is 5. Similarly, for P1, it's going to be 8 at which it got completed, but had already arrived at 2, as I said. So we are going to, it arrived at 1 units. So P1 should be 8 minus 1. 8 minus 1, that is 7. In the same way, 16 minus 2, since these are arriving one after the another consecutively, so we can directly subtract that value. 16 minus 2, this should be 14, and 22 minus 3, which is 19. Okay, now we have got this turnaround times. Now from this we can get the waiting time. We could also use the logic that I explained. I'll do that as well. Let's first use the formula. So what should it be? It should be turnaround time minus the burst or execution time. So what is turnaround time? 5. And what is the burst or execution time for P0? It is 5 as well. So 5 minus 5. So that is, it took 0 units of time to wait. That is, it got executed immediately, or it started its execution immediately at the point at which arrived. Similarly, for P1, 8 minus the burst time, that is 3. So turnaround time, that is 7 minus 3, which is going to be 4. 7. And in this way, similarly for this, 14 minus 8, which is 14 minus 8, which is what? 6. Right? And 19 minus, what is the execution time? 6. That is 30. Okay, so let's look at the waiting time using some other logic. That is, as I said, that waiting time could also be seen as the time that at which point a process arrived and at which point did it start its execution. The point at which it starts its execution. That is, logically it seems correct. Like the way at which that the point at which you arrive and the at point at which whatever work that you ought to do that got started, that was started. So if that is the case, then P1 actually arrived at point 1. So it arrived somewhere after this year 1, but it started its execution at point 5. So at this point it started. So the waiting time should actually be 5 minus 1, so that is 4. So is it 4? Yes, it is. The formula that we use may be different, but the logic accurately fits here. Similarly, let's look at for P2. P2 started its execution at point 8 and it had already arrived at point 2, if I'm not mistaken. So it's 2. So the point at which it arrived and the point at which it started. So this difference should be our waiting time. So if 8 minus 2, that is 6. So is P2 having a waiting time of 6? Yes, it is. Even if we are using the formal formula. So the logic, even if you remember the logic, you can calculate this thing. That is how we get these times. Now we can find the average time for this as well. So just add these up and divide them by 4. That is your average. In this similar way you can find for these two. So that is what we were kind of calculating. Okay, so that's it then. Thank you.